I want to introduce Marie Ma and Lahiru from Indiana University. Indiana's got a very strong gateway development program. They have quite a nice core of people, and they've been doing gateway work for many years. And what they're going to talk to us about today is some kind of common development that they've done for several different gateways that could be also extensible to others. So they've done work on several computational chemistry gateways, a bioinformatics gateway for NCGAS, the ultrascan biophysics gateway, and through this they've come out with some kind of common nuggets that are also open source, available for people to contribute to and also to download. And I see several gateway developers on the webinar, as well as several campus champions who are probably looking for information for their campuses. So I think this is going to be a really good talk. I want to thank Marie and Lahiru for putting this together for us. So they're going to split the full hour for this single topic and two speakers. So thank you very much. And with that, take it away, Marie.
Thank you, Nancy. Thanks, everybody, for joining today. We'll be having a two-part presentation. The first part of my part, I'm going to talk about the enabling XSEDE authentication for SANS gateways. So XSEDE defines SANS gateway as a community-developed set of tools, application, and data that are integrated via portal or suite of applications. This enables a variety of capabilities such as workflow, job execution, and resource discovery. So it basically provides a common interface for community users to access the underlying computational and data services and resources across several infrastructure. So proper user authentication mechanism is really crucial for SANS gateways for several reasons. First of all, gateways need to know the user's true identity in order to provide their services. While users need to be able to trust the gateways to provide them with their credentials. For example, XSEDE users need to be able to trust any SANS gateways to give them their XSEDE credentials that's associated with their actual XSEDE allocations. Finally, all the service providers also need to know the user's identity in order to keep track of user allocations and usages accordingly on their system. A general approach for the authentication mechanism normally is using authentication delegation. So MyProxy is a widely used open source software for managing security credentials. OAuth for MyProxy, that's short for OA4MP, it provides an OAuth compliant web interface for the certificate delegation that roughly works in this way. So first, when the user comes to a gateway that wants to authenticate, the gateway redirects the user to another trusted source for the user to input their credentials to authenticate. Once the user is authenticated with that trusted source, the gateways will be able to retrieve a proxy certificate from that source, and then in turn using that certificate to access several infrastructures on users' behalf. So the gateways never need to directly obtain the user's passwords or manage them. So there's only one caveat with this approach is that official OA4MP client releases require Java and Tomcat environment, which may not be easy to adopt for some gateways. In the rest of my presentation, I'm going to discuss about two SANS gateways we worked with that we provide an authentication solution for them using the approach, but overcoming the difficulty of not having the Java and Tomcat environment. The first example is NCGAS Galaxy. NCGAS is funded by NSS and that collaborates across multiple institutions, including IU, TAC, SDSC, and PSC. It provides a variety of computational and data support for biological and genomic researches. One of the core services that NCGAS provides is a Galaxy portal. Galaxy is an open web-based platform for data-intensive biomedical research. The project's core of Galaxy is developed in Python. NCGAS Galaxy utilizes the standard Galaxy distribution with a set of customized tools as a portal for the biologists to access underlying XSEDE resources, for who those biologists mostly don't need to have any advanced supercomputing background in order to use those resources. We had a talk, symposium talk on December 17th last year, and there's more information about Galaxy and NCGAS. So this is just a screenshot of NCGAS Galaxy. This is how it looks like after you log in, and on the left side there's a set of customized tools that are provided by NCGAS that biologists can use to do their computations on the IU supercomputers. NCGAS preferred user authentication requires, first of all, XSEDE users can authenticate with NCGAS Galaxy through their InCommon credentials, like using their home university's login mechanism. Secondly, NCGAS wants to be able to allow only, once the user authenticated, NCGAS wants to allow only those that have been authorized to use the Galaxy, to use their resource to continue. Well, Galaxy distribution uses a built-in HTTP server in Python, and it recommends the proxy through Apache or NGINX in the production environment. It supports 3 authentication mechanisms. The first one is just managing user accounts locally using their email address and password, and the second one is OpenID authentication. Both are not allowed by NCGAS. So now we only have the third option left, which is to use a HTTP remote user variable provided by a front-end web server. So this is a authentication method we are going to use for the Galaxy, but we need some adoption for the certificate delegation. So for the NCGAS required InCommon credential authentication, we chose to adopt a CILogon service. CILogon service supports my proxy OAuth protocol, allowing for both InCommon and OpenID authentications, so a user can authenticate with their home organizations, and then in turn access the web applications access the underlying cyber infrastructure through the web applications. So those two pictures are those two pictures are from the CILogon webpage. It describes how CILogon credential delegation roughly works. So when user comes to a web browser, they first will be redirected to authenticate against the CILogon service, which looks like the screenshot on the right. Then once the user authenticated approved and tries to access the portal, the cyber infrastructure sitting behind the portal will retrieve the user's certificate from the CILogon service, then access the underlying resource on user's behalf. As we mentioned before, there are some technical challenges in adopting the CILogon services. First of all, the CILogon client is basically just customized the OA4MP client, so it requires Java and Tomcat environment. While Galaxy prefers Python and the Apache NGINX environment. Also, Python language itself lacks the full-featured OAuth libraries that's supporting the signature method required by the CILogon's client. Once the user is authenticated through the CILogon, we need to forward the remote user's username that's needed by the Galaxy through the Apache proxy. Also, with additional authorization also is required for the CILogon authenticated users. Finally, some default CILogon identity providers, including those OpenID providers such as Google and PayPal, are not allowed by the NCGAS. Our final solution is to develop a CILogon OAuth client in PHP and come up with a set of configuration rules in both Galaxy and Apache web server to achieve the certificate delegation. So this diagram depicts our Galaxy authentication architecture. When a user comes in, it authenticates, it talks to our PHP CILogon OAuth client, and then which will interact with the CILogon service. And based on the authenticated user information, the PHP CILogon OAuth client would would forward the username through the HTTP cookie variable to the Apache web server, and through Apache web server mod rewrite rule, it will be redirected to it will be proxied to the Galaxy server running in the backend. The modules highlighted in the green box in this diagram is a part that we developed and contributed to the project. As a recap of the technical highlights for the NCGAS Galaxy, we had a PHP implementation for the CILogon OAuth client, and we provide a set of configuration rules to both Galaxy configuration file and Apache http.conf. Then we also worked with the CILogon group to have a customized NCGAS scheme so that when user is directed to NCGAS CILogon page, we are limited to only identity providers of InCommon academic institutions. So all the OpenID providers will be eliminated. And then we also had a simple PHP implementation for file-based user authorization. It's just a couple lines in the PHP file, in the PHP program. And this implementation is pretty lightweight, and we have packaged it for the general Galaxy installation. It's currently deployed and in production at the NCGAS Galaxy main page. So the more detailed nuggets of our code can be found in the GitHub on this URL. Finally, here's the NCGAS Galaxy authentication, the production page, how it looks like. If you go to https://galaxy.ncgas.org, you will be redirected to a page like this that's customized NCGAS CILogon page, and where you can select your own home institutions from the list of identity providers and authenticate using your home campus method. For example, if you are from Indiana University, you will be redirected to IUCAS authentication page. So this is our work about NCGAS Galaxy. Next, we'll talk about another case study that's called GAAMP. GAAMP is a software developed by Ruth Lab at the University of Chicago to provide a range of tools and services for automatic force field studies in the biomolecular computations. The GAAMP XSEDE Gateway is a lightweight portal developed in Python CGI to help XSEDE users utilize GAAMP across XSEDE computation resources. This is how current GAAMP XSEDE Gateway looks like. It actually doesn't have any XSEDE authentication mechanism at this time. What it does is XSEDE users, when user comes in, the XSEDE user account information is collected through that web form you saw in the previous page. Then the GAAMP gateway will generate and package all the necessary files needed to use GAAMP on the corresponding XSEDE supercomputer. Right now it's Tressos or Blacklight. And then the GAAMP will generate a tar file for all the necessary files. The user will download that tar file from the GAAMP gateway page. Then user will go back to log into their corresponding XSEDE supercomputer themselves, upload the tarball they got from the GAAMP gateway, and use that to submit their jobs and run their computation. So for the GAAMP XSEDE gateway, the user authentication would have required two things. First, we want the XSEDE user will be able to authenticate with the gateway. Secondly, we want the GAAMP gateway be able to submit jobs on user's behalf, so that the user doesn't have to do the manual steps of downloading the tarball and logging to their supercomputer and submit jobs, and also that we can automate the whole job submission workflow. Our XSEDE OAuth supports OA4MP delegation services for gateways. So our approach basically was to adapt NCGAS CILogon PHP client, adapt that for the XSEDE OAuth. It actually turns out to be pretty simple adaptation. We only need to do two changes from the previous CILogon client. first we need to modify the OAuth endpoints. It's just 4 lines of URL that we need to change. And then in the NCGAS CILogon case, we only needed, once the user is authenticated, only the username is needed by Galaxy, so we only forward the username to the Galaxy. While in the GAAMP case, we actually need a user proxy certificate for the later job submission. So we modify the client a little bit to save the user proxy certificate to a file, so that the rest of the GAAMP workflow can use that certificate. So just another few lines of change in the client. Now the client is ready. Then the client is ready to use for GAAMP gateway. So once the user first comes and talks to our PHP client, once they're authenticated, they will be redirected to GAAMP gateway and with their proxy certificate file information encoded in the cookie in the HTTP request. Then the GAAMP gateway will then in turn submit jobs through XSEDE resources through the GSI-SSH on user's behalf. This diagram shows our GAAMP XSEDE authentication architecture. The user, as we talked about before, user comes in, talks to the green box of the PHP OA4MP client is the part we contributed. So user comes in, talks to interact with the PHP client after they're authenticated through the XSEDE OAuth page, and they will be redirected to the GAAMP gateway and with their proxy certificate embedded in the HTTP cookie request. Then the GAAMP go ahead and submit the job through GSI-SSH to either Blacklight or Trezor. As a recap for this project highlight, we had the XSEDE OAuth client implementation that's generic and it's pretty easy to adopt for other gateways. It's currently under deployment for the production GAAMP server, and you can also find our code that is also open source and available at the GitHub. So our outcomes for the 2 projects just discussed as follows. We had XSEDE authentication solutions for 2 projects. One is NCGAS, which is currently in production, and we're also following up with the XSEDE Galaxy efforts that's led by Phil Blood. Another one is for GAAMP, and it's currently under deployment for production. We have code nuggets available for other gateways to adopt and use. So if you have a Galaxy instance, or you want to use the version we had for the NCGAS, that's mainly because of Galaxy proxy requirement, there's a set of configuration rules that you would need in the Apache http.conf. Otherwise, if you have a more generic XSEDE gateway, you could use our GAAMP version of the OAuth client that's pretty generic and should be easy to adopt for other similar cases as GAAMP. And our codes are available, and we have some experience in doing this, and we'll be happy to help if you are interested in using the code, and if you need any more information on how to use them, or let us help you adopt the code. And so our contact information is the gateway's mailing list. Next, I'll turn hands over to Laru to talk about the job management, job submission, and the monitoring. Before I turn the hands over, is there any more questions about this part?
Yeah, hi, this is Amit. I have a bunch of questions. And my understanding of this authentication stuff is very naive. So I would like to understand where things differ. Why go through CILogon and so many other things rather than just using Shibboleth InCommon? And then how does this work differ from the NERSC NEWT toolkit, which is all Python, and if that can be leveraged? And the final question is that the PHP stuff which you guys have made available on GitHub, is that standalone or it depends on some IU-related services? And if so, what is kind of the uptime and guarantees that stuff kind of works round the clock? The people who would rely on something like this, if they choose to use that. Okay,
so I think for the first question, I think CILogon basically just it's a central service sitting in front of InCommon shiplets, and it's just simplify. I think it just makes the implementation easy, so that I don't have to know the detailed implementation about how to get adopt the shiplet framework into my code. All I do is I just set a URL to CILogon, and they will do all the backend handling for me. And as to the third question I think the PHP clients are standalone and they don't depend on any of IU resources in the back. I didn't quite get the second question.
Oh, the second question was this NEWT toolkit from NERSC. That has some authentication stuff built into that, and it's all Python. I'm not sure if you have come across that or not.
No, I haven't come. I don't know much about that part. I'm sorry.
All right, I'll send you a note. But I have a related question. When you mentioned this stuff about the CILogon, and you mentioned that CILogon and MyProxy requires Java and Tomcat. However, Shibboleth and InCommon offer a PHP direct environment to work with. So you found that is quite difficult to develop against, and then you chose to use CILogon?
Well, I actually didn't try with a Shibboleth PHP environment. Okay,
that's fine. I mean, I'm just curious. Don't take this the wrong way. I mean, one thing which comes to me is that is XSEDE authentication not available through InCommon? That would be one limitation, I would guess. Or it's only available through InCommon. Is that also one limitation, perhaps?
So when I talk about XSEDE authentication for the GAAMP, I meant so the user need to have a specific account for the XSEDE portal, and they also need to have their XSEDE allocations that's associated with their account in order to use a GAAMP service. I don't know if it's actually part of. I don't think it's part of InCommon. I'm not sure if I don't think it's part of the InCommon. Listed as part of the InCommon provider.
So if I may request you or someone from IU, Suresh, if he's there, I think some of the users like me will greatly benefit from a short presentation about what this authentication and authorization madness is all about, because there are too many moving pieces, and and it obviously requires too much work. It would be good to have some understanding of how this whole magic is kind of happening.
So yeah, I guess we need to discuss with Jim Bassney from and about their services, and they can give more details.
Okay, I mean, what I'm asking is that a general, a concept level presentation about what is going on and what are the tools, what things are required. I think that would be beneficial, because more and more we come with users who are interested in developing gateways, and it would be good to know what the requirements are and what kind of things are available. I mean, these presentations are great, but I think a conceptual overview would be very, very good.
Yeah, sure. I think we can talk about that afterwards.
Yeah, so that's a really good comment, Amit, and that's a bit of a staff training sort of thing that we could open up to others as well. So you're right. There's more and more interest in building gateways, and just a general authentication overview. These are all the different ways you can go about it. So I've written that down. We're always looking for additional training topics that come out of these symposium discussions. So that's a really good one. I know a little bit about Newt. I haven't looked at it for a while, but when I talked to Dave Skinner about it, the way they were approaching things is they have their set of command line supercomputing users, and what they've done, their approach to gateways has been to build some tools that enable regular command line folks to then broadcast out data sets and things like that. So rather than the XSEDE view is kind of you have your own login on your gateway website, and then you submit jobs. and the jobs run on XSEDE as a community user and that sort of thing. Theirs is much more geared to be kind of additional features for the command line users. So like designated disk areas that are outward facing to the web and things like that. I haven't looked at it for a little while, but when I looked at Newt, that's what I remembered about it.
Yeah, that's great. I mean, I was just reading about it yesterday, and then one thing which appeared to me is they seem to be directly authenticating with the machine itself, which may be a limitation for gateway, because if the machine changes, you need to have all that glue to talk to different machines, which might be a unique requirement for gateways as opposed to, NERSC users, which only have, one or two sets of machines to work with.
Right, exactly. And GAAMP is a little bit like that, too, in that it's accepting, regular user portal credentials for accessing individual allocations. So it's definitely a different kind of model geared towards people who have their own allocations and now want to use these computational chemistry tools but sort of apply their own allocation to it. So it's kind of interesting. We're seeing gateways expand and change in different ways as the years go on, and that's one different way. So, yeah, sorry to interrupt there, but good questions. Questions from anybody else on the line before we hear from Lahiru? Yep, great. Go ahead, please.
Hi all, and thanks for joining the call. So today I'm going to talk about two tools that I have developed as part of ECSS gateway projects. Like when I was helping different ECSS gateways, I realized there are some common functionality that I can implement independent of the domain of each gateway, where some other gateways can consume. So what I basically did was implemented those functionality in an independent way so that somebody else can download those tools and then simply plug those tools to their own gateway and then consume it. So during my talk, I'm going to explain the functionality of these tools and explain the design decisions, and then basically show you how to consume these tools. So my idea is just to give a startup kind of a thing for the audience, if in case that they are looking some library to perform these tasks, so that they can just download it and try it out, and then from that place we can start the communication and then help each other to use these tools. So basically these tools are like you can see the source code, and then if you have any questions about issues or maybe improvements or maybe functionality, how to use, you can email the gateways mailing list so that I can respond to those emails. So that's basically my overview of the talk. So if we take a science gateway is kind of an abstraction between the application you're running in XSEDE resources, rather just directly talking to the XSEDE resource. We can build either a portal or either a desktop client to communicate with the resource and run your applications. So basically, science gateways can communicate with the XSEDE resource using a middleware, or we can directly communicate with the local resource manager in the machine. So basically, currently we have, as middleware standpoint, we have basically GAAMP and Unico. So currently there's a lot of science gateways consume GAAMP services to communicate with the XSEDE resources, and there is another middleware called Unico, and people can use Unico to do their job submission and job monitoring tasks, and third one is directly consuming local resource using GSI-SSH. So today I'm trying to explain the tool that I have developed, which basically consume GSI-SSH. So these are the gateways which consume GSI-SSH to do their job submission. GridCam and CyberGSI and Cypress. They use GSI-SSH in different ways. Basically, GridCam use unified scripts to submit jobs, and CyberGSI basically create a command and with all the parameters, with all the arguments, and then do a queue sub and then submit the job. And then Cypress basically use a Java process and fork and SSH command and submit the job. So these are basically the three well-known gateways which consume GSI-SSH for their in their science gateway. So after going through these gateways, how they have developed, I thought of developing more programmatical solution so that gateway developers can basically use this programmatical library to program against a program in their gateway. So basically, like if you fork a command in a remote machine, you basically lose your control because it's just like running a command. So if you don't use a library, you don't know whether it gave error or successfully ran or something like that. So and these scripts are somewhat like different from each job manager. So in XSEDE machines we have PBS and Slum running, so each use different job submission scripts, and so I thought of if we develop a more lightweight and very extensible API, so the Science Gateway developers can basically consume and download the software, download the API, and then if they want to extend, they should be able to easily extend based on their use case, and then use the underneath the functionality. So there are basically like a few implementations I found. So first one is GSI-SSH term, which is basically doing like it's mostly like a terminal application, and it has a UI. Then you can submit jobs, and then they use this GSI-SSH term project use CogJ Globus and J2SSH as underlying libraries to do the authentication. And so when I look into that, it's kind of difficult to make it as an API because it wasn't developed to release it as an API. It was like mainly a ready to use terminal applications where you can download it and into your desktop and then use to submit jobs to the XSEDE resources. And there is another Eclipse project developed using L-crypto libraries. So it's again Eclipse-based implementation. So they use JCraft to do the authentication, and then you basically download the MyProxy certificate to your local machine, and then communicate using JGlobus. So I think XSEDE has moved to use JGlobus to do the authentication, and Eclipse P2P Project use the latest library that XSEDE is supporting. So it's again similar to GSI-SSH system. It's ready to use Eclipse plugin, which is it wasn't a target towards a library type of solution. So with our approach, what we wanted to do is like borrow the ideas from these two projects and then implement a more programmatical API, and then we decided to support JGlobus 2 because it's the latest library that XSEDE supports to do the authentication, and we use JCraft to do support SSH communication. And what we did was we basically took the JCraft latest release and then extended the JCraft implementation, rather modifying the JCraft source code. So because that leads us to use the future versions of JCraft without doing a lot of code level changes in our library. So we basically extended the JCraft to do the MyProxy authentication because JCraft doesn't support any MyProxy related features. So we took JCraft and then implemented a MyProxy authentication using JGlobus 2, and then on top of that we support multiple SSH related utilities. So we wanted to keep this API more simple and then basically easy to extend for the gateway developer. So this is basically the structure of the job submission API. So we have inbuilt support to GSI-SSH authentication and SSH authentication. We can, with the SSH authentication, you can use username, password, or maybe public-private keys. And with the GSI-SSH, you can use MyProxy credentials with certificates, paths, and all. So on top of this authentication layer, we came up with a generic way to execute commands in a remote machine. Once you authenticate, you can tell, okay, I want to run this particular command, and I want to pass the output of this command. So it basically consists of two components. This generic command executor layer, where you give the command and then you tell how you want to pass this message, how you want to pass the standard output and standard error. So, and on top of that, we have implemented generic SSH utilities where people heavily use in Science Gateway, job submission and job monitoring. So basically like a few features I'm going to talk in next slide. So on top of this SSH utilities, we implemented PBS support and Slum support, and if there is any requirement to use another job manager, consume another job manager, users can just extend the job submission API and then use the underneath functionality to execute commands and read output, standard out, standard errors. So with the PBS implementation, what we basically did, it was like we went through the PBS spec and then implemented a generic XSLT, and then same with the Slum, and we have a generic XSLT, and then we have a common way of representing a particular job, which consists of a large number of parameters, and we pass our object job object through the XSLT and then generate a script. So basically, based on the machine that you are running your job, you might want to tweak some of the parameters of your PBS scripts. So this is not a hard-coded thing in the library. So if you want to do a small change, you just have to change your XSLT, and then it will dynamically pick the changes at runtime. So we basically internally developed some of these PBS custom versions of PBS we have at Indiana University to support Big Red 2, which is Indiana University resource we have here. So if I talk a little bit about the features, so we have basically, you can use this library to do file operations, the basic file operations like creating directories and then list outputs and transferring files and create batch scripts, and main task is submitting a job based on the job manager. We currently support QSub and SBatch for Slum, and so we support monitor jobs, like very basic monitoring, where like you give the job ID and then get the status for like a quick one. So but next set of slides I'm going to talk how we do proper monitoring with another tool. So so these are the basic functionality we support in the job submission API. So this is a simple code example. I just wanted to show you like the steps that you need to do if you are a Java programmer or a gateway developer. You can just see what are the basic steps. Where like here I'm doing a simple SSH authentication. In a future slide, I will show you how to do the MyProxy authentication. It's pretty straightforward. So you create a default password authentication if you have a password. If you want to do SSH keys, you create a new public key authentication and create a server information where you want to run this. It could be Trusses or Stampede or something like that. So actually this code was written to run some jobs in a local machine we have here, which runs PBS. So that's why it uses username, password, or public-private key authentication. So for XSEDE machines, we can use MyProxy authentication. So once you get those information, you create a job descriptor, which basically describe your job, give the executable and mail options and standard out, number of nodes, processes per node, and all this wall time and all these things. Once you fill out this job descriptor, you just pass the job descriptor to the submit batch job method, and it will basically return you the job ID. So based on the implementation, if it's Slum, it gives the output in a different way. So we have multiple output passes for each manager, job manager. So we return the job ID with a successful job submission. If we fail to submit a job, what this does is we basically read the standard error from our job invocation and return throw an exception so that programmatically you can catch that exception and see what's wrong is happening in the remote machine. So that's the strength that I see in this programmatical API. So where you have the control how to handle errors and everything, which is not hidden using another middleware like GAAMP or Unique or something like that. So this for the job submission API, you can download the code from GitHub, or you can download the code from Apache Git and build it from using Maven. And if you have if you have MyProxy credentials, you can use this particular parameters with your Maven command and run the test. If you don't have any MyProxy credentials, you can just skip these tests and build the tool and use it. So next part of my presentation is basically how the monitoring tool that we have developed. So with regards to monitoring, we think there are basically like two ways we can monitor a job. We can either use a push model or maybe a pull model. So currently XSEDE supports AMQP based push monitoring, and then we consume that AMQP service basically done by Warren Smith. So it's pretty easy to use and easy to use service where I was able to just look into Warren's sample quickly and then port it into my tool in like 2 days or something. So and then the other approach we had was pull monitoring, where I go communicate with the resource and continuously poll what is my status by giving the job ID. There are multiple ways that we can do. We can monitor. We can poll the status based on the user to minimize the load we run in the head node. So likewise, we have done some optimization to make sure that we don't stress too much to the head node. So basically, with PBS we support QStat, and then with Plum we support monitoring jobs using SQ. So this is the architecture. This is the AMQP architecture where we use for our push monitoring. It basically use the it reads the job information from QStat file and basically publish those messages to RabbitMQ bus. And what my job monitoring library does is it basically do a subscription based on the user. So if the tool gets multiple user requests for multiple jobs, I'm not going to start a listener for each and every job. So I filter out the username. So based on the user, I do multiple subscriptions and then read those notifications, AMQP notifications, which basically send me notifications based on Bluetooth schema, and I pass the status and all the other information and consume those notifications. So that's about the AMQP monitoring. So if you have any questions about how this has implemented, how to use, I can also answer. But Warren Smith is the right person to ask about the implementation details. So this is the architecture of job monitoring tool. So we basically have a queue-based approach. So we have a queue for pull monitors and then push monitors. So job manager is the object that the gateway developer has to program against. If you have a job, you just create the required information and put that job into one of these queues. It could be pull or push. So it has to be, the decision has to be taken by the gateway developer. So once you put some job into one of these queues, these monitors go pick each and every job at a time and then start monitoring. So
well, I got it set up with Bolton, but I don't seem to be able to reach it from the web page. Getting a strange error message about the messages.
Here, somebody else is. Maybe I'll mute the participants here. Just a second. Yeah, this job monitoring is really important because we've seen gateways who have to monitor very closely, kind of hitting the login nodes quite a bit, and that causing problems for queuing systems and things like that. So it's really nice to see this messaging service.
Yeah, so what we basically do in this library is just consuming Warren Smith's service. It's like a client for his service. So once we get the statuses, we have a internal event bus. So everybody publish their statuses to the internal event bus, and then you can write your own listener for performing some actions for those statuses. So right now we have a login listener and a registry listener. These listeners are configurable. You can write your own listener and make sure that you subscribe for the event bus and then perform some tasks.
There's something wrong with the SSL connection.
Yeah, I see Warren on the web conference. I don't know if he's listening at the moment, but
yep, I'm here.
Yep, great. So
one little clarification: the job updates are coming from the scheduler log files in the clusters. So they're very fast to arrive, and there's no overhead of doing QStats to get the information.
On the other machine where there's some kind of
right, yeah, which was pretty important because I mean the gateways want up-to-date information, but all those QStats were creating quite a load, especially if you've got an increasing number of gateways and numbers of jobs. It can be a real problem.
That's a problem.
Yeah. And actually, separately, I'm also publishing kind of QStat information in different messages. So you can get both per job updates, and every minute or two you can receive essentially a QStat output formatted in this glue2 format.
Great.
Yeah. So basically, like if in job monitoring library, if you want to completely get rid of job QStat monitoring, it's just a change of the parameter in a properties file. So we have a properties file for all the monitors. You can write your own monitor using some other mechanism like like something like SQ. I think, Suresh, there's some other ways to monitor, like SN4 and all these things. So you can write your own monitor and then just configure the library. So it's a configurable thing, so it's not hard-coded or anything like that. So if you don't have AMQP support in one machine, then you just can remove that monitor from your properties file. So these are extensible, the registry listeners and logging listeners and all these things. So if you don't want to use the inbuilt logger, you can write your own logger and then subscribe to the event bus. So this is a complete code where I start my monitor and submit a job and start listening. So here I create my monitor manager and then create an AMQP monitor, which is using XSEDE AMQP bus, and then add this as a push monitor. There could be multiple push monitors if you want to implement, and then once you launch monitor, this launch a daemon with each and every monitor that you have added in this level. So right in this code we have only one monitor, but like this we have implemented inbuilt SQ and QStat monitors. So those things has to be added to your pull monitor list. So once you add these things and start launching this API start daemons and then start listening. So here we use same code to submit a job using the tool that I was talking in first set of slides. So once you submit a job, you get your job ID. Once you get your job ID, you create this monitor ID object with all the information, and then you add this job to monitoring queue. So once you add this, daemon start monitoring, and then event bus will be having statuses of these jobs. So that's the easy steps to submit a job and then start launch your monitor. So this is kind of like a recap about what we were talking. So we basically have job monitoring, and then file transfer operations and job submission abstract. These three boxes can be implemented using the two tools that I described, and then job submission will be through GSI-SSH, and file transfer will be basically SCP, and then job submission can be either pull or push QStat or AMQP or SQ. So that's the basic structure once you develop your Science Gateway middleware using the tools that I described.
You sent to those people security. You told them this address.
Yeah.
And
that's terrific. Lahiru, there's somebody else talking in the background. I'm not going to mute because we're just about at the end of the call.
Okay.
But if you have any additional questions for Lahiru?
Isn't that your software?
No, I don't think so. I didn't see that the other time.
Well, I think thank you very much to Marie and Lahiru for their talks. I think this definitely points out the need for kind of backing up a step and having a higher level presentation on different authentication models and things like that. But I thought the nuggets descriptions, especially for the job descriptions, were very, very applicable to a lot of gateways. And the more and more gateways we see in XSEDE, the more it's going to be important to kind of design these things scalably so the systems can support them. So I think this is really good work. And let's see, the slides will be up on the symposium website, as will the recording, and there's also contact URLs for Marie and Lahiru, so you can ask them further questions that way.
Okay. Thank you.
Yeah, thank you very much for taking the time to prepare such good presentation for us today.
Thank you.
Yep. Thanks everybody for joining.
Thank you.